Hello everyone and welcome back. My name is Mr. Kovald, and in this video I'm going to be going over how to calculate the standard free energy change in a chemical reaction, method number 2. In the last video I talked about method number 1, which was to use the equation of the standard free energy change of the reaction is equal to the standard enthalpy change of a reaction minus the temperature multiplied by the standard entropy change of the reaction. But here in method number 2, you could actually just use tabulated values of free energy of formation. So this is very much like the calculation of the change in the enthalpy of formation of a reaction. So just like the enthalpy change of a reaction being a state function, so are free energy changes. So free energy is a state function, which again means that the state function or this particular function does not depend on how you got from A to B or beginning to end. So my analogy that I've used before is the analogy of going from the ground floor of an apartment building or a hotel to the top floor. So the change in my potential energy, my gravitational potential energy, does not depend on how I get to the top floor. It only depends on my potential energy that I started with at the ground floor and the potential energy I end with at the top floor. So I could either take the stairs to get to the top floor, or I could take the elevator to get to the top floor. Either way, the change in my potential energy is exactly the same, independent of how I got to the top floor. So the same thing with free energy. It doesn't matter how you got there. It just matters what the change is, right? So this is only going to depend on then the starting free energy of your reactants and the ending free energy of your products. So since we are only interested in the changes of free energy, so we're not interested in absolute values of free energy, we're only interested in the changes of free energy, we can then define the zero of free energy as conveniently as possible. So just like we defined the zero for the enthalpy of formation of elements, we define them in the same way for the free energy of formation. So here is the definition of free energy of formation. So it's the change in the free energy when 1 mole of a compound in its standard states forms from its constituent elements in their standard states. And the free energy of formation of pure elements in their standard state is 0. So this is very much like the definition of the heat of formation. What is the heat of formation? It's a change in the heat or the enthalpy of when 1 mole of a compound in its standard state forms from its constituent elements in their standard states. And again, the enthalpy of formation of elements in their standard states is 0. So this is very much the same definition as that of the energy or heat of formations that we saw before. So using this definition, we now have the equation of finding the change in the free energy, the standard change in free energy of the reaction by the tabulated free energies of products and reactants. So just like we saw before, you can calculate the change in the standard change in the free energy of a reaction by looking up the free energies of formation in tables that you can easily find either on the internet or in the back of your textbook or something like that. So just like before, the change in the standard free energy of a reaction is going to be equal to the sum or the addition of the free energy of formation of products multiplied by the stoichiometric coefficients that are found in the balanced equation. And then you're going to subtract from that the sum or the addition or of the free energy of formation, the standard free energy of formation of the reactants multiplied by their stoichiometric coefficients in the balanced equation. So you can use this equation to find the change in the delta, the change in the free energy of formation of a reaction. And so what you'll find when you look in the tables is that the free energy of formation of elements or of a lot of products or compounds is going to be negative, right? And all that means is that the those compounds spontaneously form from their elements. Some compounds are going to be positive, and that means that if the free energy of formation of the compound is positive, that means that those compounds are not going to spontaneously form from their elements. So you're not going to be finding those very often in nature. So I hope this is a helpful video. I hope you learned something from it. If this was helpful in any way, please, by all means, like this video, hit that like button, share the video, please, and hit that notification bell right up there. Subscribe to my channel. That way you can be notified by other videos that I put out. And finally, make sure you put a comment down in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me, and have a great day.